Programming Throwdown, episode 177, Vector Databases. Take it away, Patrick.
Welcome, everyone, to another episode. We have a great topic today. I'm excited to learn. It's legitimately something that I hear all about, but I don't know too much about. So we're going to have teacher Jason joining us here in a minute.
That's right. We had teacher Patrick for compilers and interpreters. And then we have now teacher Jason for vector DBs.
I feel like we should have called ourselves professors. We have a missed opportunity there.
Oh, that's right. Is there anything higher? Distinguished, emeritus, professor, emeriti?
Okay.
What's the highest level professor? Title.
ChatGPT. Can you sole emperor of the knowledge universe? Oh, but what if it thinks it's the smartest? It's going to tell you a lie because it doesn't want you to be superior. Okay. Anyway, no, sorry.
Oh, I have this plan now when I get these calls from people telling me that my taxes are overdue or I should buy car insurance or whatever. What I've started doing is asking it questions about particle physics. And when it gives me really good answers, I'm like, aha, this is ChatGPT. This is not even a real person.
A particle physicist could work in a call center. Okay, yeah. I mean, I had to go looking for a car, and they legitimately want your phone number, or whatever. So I just have one of the I guess it's a voice over IP number, but it doesn't actually ring through or whatever. And one of the places I went has called me twice a day, every day for going on 2 weeks now. And I've picked up zero of the calls. And I'm just like, they really want to sell me a car. But it turns me off. I'm just like, why are you pestering me this much? I feel like just text me.
I will. So, my dad worked for a few different car dealerships over the span of about 30 years.
Oh, wow.
And so I learned the trick to buying a car. And I'll share it with everybody. If you're a Programming Throwdown listener, for free, you don't have to be a patron, although we really appreciate it. If you want to buy a car, here's what you do. You show up, you test drive the car in person. So they know you're a real person. You're not another dealer trying to buy a car and then resell it. You're there as an individual to buy a car. You prove it to them, right? And then you leave and you don't come back until you have everything finalized. So everything is over email or phone. You negotiate the price, you compare with other dealers, and you should expect this to take about a month. But if you do that, you will save anywhere from 10 to 30% of the price.
Wow. Last time I bought my car, I feel like it was pretty different than now in that the inventories are much worse. But yeah, in general, I did something similar to what you were saying for the last time I bought a car. It was super nice. I just showed up, all the paperwork was done, just basically, it still took, close to an hour, which is ridiculous. But pretty much it was all ready to go. So yeah, I agree. I'm going to attempt to do this one again. I haven't gotten to the negotiating stage yet. So, but showing up, I guess they're trying to, do the CAPTCHA with me. So they're trying to call me back and make sure the phone number is real.
Yeah, I haven't bought a car since 2020, and so I've missed this shortage. But is the shortage still a thing, or is it over?
I don't think it's a thing in the same way, but the inventories on desirable stuff is still not great. And at least at the places I was looking, I think it varies dealer to dealer how much they've or brand to brand, I guess, how much they've recovered. I think it's still on. The pricing is tighter, but I don't know. I will still die on the hill that I think we are stupid for having gotten ourselves. And I guess this is US centric. People tell me in other countries it's not like this, but really? I have no idea why you go in and the only place in life remaining is a car dealership where you have to negotiate. I'm going to bring in my manager. I'm going to bring in the finance. We're going to change everything on you. It's a total scammy thing the whole way through.
Oh yeah, that's another thing. So the thing about finance, you ever play these mobile games where there's 24 different currencies?
Yes.
I play FIFA on mobile, and there's literally five to 10 different currencies at any given time, and some of them get phased out and replaced with other currencies and all that. But there's one currency that you could pay real money to get. And that's ultimately the only currency that really matters, because that's the one that's tied to USD, right? And so if you start going down the finance route early, you end up in this boat where they're like, oh, your monthly payments are the same, but like they added a year of payments, but each month is the same. And there's just like too many variables that it's like pretty easy to get tricked. And so that's another thing that my dad told me was like, always like negotiate the absolute dollar amount and then come in at the very end and do financing after like you're ready to pay the amount or whatever.
So this has turned into a little bit of advice from Jason and a lot of whining from Patrick. So, but yeah, buying a car, I look forward to, I will say from what I understand, Tesla does it a little different. I look forward to, some future for my children or whatever, where like you literally just figure it out online. Maybe you show up to test drive once and then you just buy. And it doesn't matter if you buy from the one on the west side of town or east side of town, it's all the same, like every other thing we go to and do. So
yeah, exactly.
Can't come soon enough. All right. And I'm sorry for all the car dealership people that I probably, very frustrating to or putting out of business, but
Yeah, if you're a car dealer, message us. We'll take your hate and read it on the air for everyone to hear.
Oh no. All right, we're jumping into news. All right, so my first article talking about programming things here. Cognitive load is what matters. So this is actually a GitHub article, which is kind of an interesting way to do it. So the person can update it over time. And this is something that I picked, I will say a little selfishly, because I say this all the time at work, and there'll be a link in the show notes. But just talking about in development, that in software development, one of the most overlooked things is how much cognitive load you're putting on the engineers. And this can come in a couple forms, and they kind of call them out. Like sometimes that could be the business surrounding the code. I work at a place that does like lots of software engineering. So it's a pretty like respected part of the business, but in a lot of businesses, you may only have 1, 2, 3, 4 software engineers building something. And so the bulk of the business isn't really the development or the software. And so there's all sorts of like, hey, you really need to work with the accounting team and this team and that team and who talks to whom, and this is using this database and this person's using this other one. All of that has to be loaded into your head. The other thing I always bring up that people forget is you go to college and you learn all this stuff about compilers and programming, and you show up on the job and they give you like an unconfigured Linux box. And maybe you've only ever used Windows or you've only ever used, Mac OS. And now it's like, hey, here's this Linux box. Congratulations. Like configure it, install all your packages. Oh, you need to like, move your PC to a different location and plug in all the cables. But wait a minute, like, is that really like a requirement listed for the job that like, Bash or ZSH or any of these shell scripting? And so the amount of cognitive load that goes into programming and then, to I think kind of the bulk of the article is when you're selecting paradigms, abstractions, where to divide stuff, how much to copy and paste, there's a balance to be reached. If you make, stuff too small and modular or too monolithic, both introduce a lot of cognitive overload. So there's the balance there, but actively thinking about how do we build this in a way that makes it easy to reason about? So things that are similar are kept together, and not abstractions for abstraction's sake is an important thing. The one that always gets up, like we program in C++, and it's like everybody, look, I wrote the ternary operator, which is you write a, conditional expression, like an if statement, A greater than B, and then you do a question mark. And then the first thing is what happens if it's true. And then you do a colon, and then you put the second thing. Okay, just write an if else statement or an if then, like you are, I've been programming for a long time. I see it. Yes, I can parse it, but I don't parse it as fast. And I always have to double check, like, wait a minute, it's the true is the first one, false is the second one. And secondly, when we bring on a new person, maybe you say, hey, we're all experienced people. And this comes up in a later news article. But when new people come on, maybe they aren't used to that. So using, and this matters for some languages more than other, but using like the subset of the language that is most comprehensible and most widely used gives you benefits in that it's very easy to bring new people on. It's very easy to teach them. We were working with a code base where they've like put in a ton of macros. all of the variable names are single character variable names, all this stuff. And they may be efficient in programming it, but you cannot work with them. You can't work with that code base. And all of this is about that, thinking about cognitive load and really programming in a way that reduces it.
Yeah, I've seen so much kind of bad behavior with macros and meta programming in C++. It just makes it so difficult. It's like, I'm using like the double hashtag thing to like concatenate different things in the preprocessor, and like, I'm auto generating classes, and now I have this call to a preprocessor macro to create a class, and I'm doing that call like 30 times, and so none of these classes actually exist anywhere. So like, it messes up the IDE and everything, and at some point it's like, look, if you were to copy paste this class 30 times. Well, first of all, there should be a better way of doing it. But let's say you just couldn't figure it out. Just copy paste the class 30 times. At least that way someone can see kind of the point and the pattern and all of that. If you hide it behind a preprocessor macro, it just becomes like a tar pit that people get stuck in.
And I think there are other languages that the same thing happens, or even, the way of doing object modeling. And I've seen stuff in Java with, getting into dependency injection and reflection at runtime, and just like, it makes it really hard to like, hey, I have a call site here. What code is being executed? Like, how many hoops do you have to jump through if you don't know off the top of your head to find the actual line of code invoked? And how confident are you that you found the actual line that is being invoked? And if that is not a trivial amount of time, you should be really, really thoughtful about trying to reduce that as much as you can.
Yep. Yeah, totally. Dependency injection is in Java. I remember, I forgot what the tool was called, but there was this tool where like maybe it was part of the Spring framework, but you would pass in like a config, and it would create classes from this config and feed them into your main function. And so it's like, oh, like this object is already filled in. What the heck? Like, how do I change it? Oh, it's actually in an XML file. It's like, what? It just became really hard to use. Moving on to diffusion models are real-time game engines. I don't know. I don't necessarily agree with the premise of this, but the thing about this that blew my mind is the video. So basically, what people did is they took these like image generators and text to image, that whole like vision transformer kind of technology, and they basically used it to say, if I have this image of a screenshot of a video game, in this case, they use Doom because it's open source and people use it on everything. So given this screenshot of a Doom game, or maybe even like a handful of screenshots of the last second of this Doom game, and given a command like shoot a gun or go forward or whatever, then generate the next screenshot of the game. And so they basically are trying to encode the entire Doom game, like the art assets, the engine, everything, into a diffusion model. And so then they proceed to play this game, and it just gets kind of weird. Like like points of discontinuity are really difficult for these models. Like, so for example, when you fire the weapon, sometimes it doesn't fire. You get the fire animation, but like, the world isn't affected. And other times it is. Sometimes like you walk and a door is just kind of like flickering in and out of existence. The whole thing is wild. You really, we're not doing it justice here over audio, but go to the show notes and watch the video. It's just pretty, I've seen a lot of like weird things with Doom. Like they passed it through Daydream, and they have this like really weird, kind of like trippy kind of, view of it. But this is really taking it to the next level. Like you're defying the laws of the game are not first order anymore. So it's like sometimes the world works the way you expect. Sometimes it doesn't, and it's just kind of insane to watch. So.
There's a couple games that kind of do something that it reminds me of. So I actually have seen this one before. And like you're saying, it's kind of weird because it looks like you're playing the game 90% of the time or whatever, but then occasionally something happens that is different. So like you're looking one way, you turn around and face the other way, and then when you turn back, the world is completely different. Like you're not in the same place, or like the world has shifted because it's generative. So it's just doing the whole thing sort of like on the fly. So you almost convince yourself it's right. And there's a game, I think it's Superliminal. I don't know if you've played this, that has stuff like this. Like you can go through a door, and then when you come back through the door, like you're not in the same place. It's sort of, I don't know, call it like non-Euclidean or whatever. Like, it kind of plays with the sort of like perspective. And so like if something changes size in your perspective, it changes size in real life as well, in the game as well. And so there's all these things you can do where it sort of subverts your expectation of a game modeling reality. And it doesn't mean it's not fun to play. It's just it can be very fun. I don't know, in these cases, maybe it probably wouldn't be very fun. But it is just like this weird twist to your brain.
Yeah, totally. I'm pretty sure you can't get much beyond the first or second level in this. I mean, this is like some academic exercise. But yeah, I just think there's something just kind of wild. I mean, it's definitely something I've never seen before, where someone tries to like imitate an entire engine of a game with a neural network and then see what happens.
People with too much time on their hands? No, I'm just
Well, people with too much money in their hands, right? Because of the AI hype cycle.
Oh, there we go. Well,
yeah, I mean, maybe that should be episode 178.
Someone get sent some our way. We'll try some of this stuff.
Yeah, that's right. Yeah. We're currently raising, we have a new model. It's called Claude, CLAWED. It absolutely does not just call Claude under the hood. Please give us $50 million.
Oh, I've seen some of these accusations going around about people just calling other models and saying, yeah, okay, anyway, we're moving on. This is the AI gossip, I guess.
Yeah, that's right.
My next article is kind of related to the previous one. Your company needs junior developers. And so, again, I guess a bit biased, is something I push for all the time at work. It's a strongly held personal belief. And so the idea here, a lot of places, I think you can fall into the trap of, hey, we want to hire a senior person. The inside joke, I guess, that goes around is like you read resumes and it's like, hey, you need 10 years of experience with a tool that came out 2 years ago. And just like everybody needs to hire the utmost expert in the field. And in practice, that's not really true. Most of the time, that isn't. It's not to say that there's never a good idea to hire senior people. But I feel by default, most folks have this belief that like, hey, we're high velocity. The way to like keep this up is just keep adding people at the same level of the team or above the level of the team to bring them up. And in some cases, that may be true. But I have found that often there's a number of first and second order effects that come from hiring junior developers, and I'm not even talking about like budget, money reasons. I'll leave all that aside. Hiring junior people and being able to train them like helps them sort of they are more plastic towards how stuff is being done and learning if they're inquisitive. And it's not to say that they won't express their own opinions or bring changes. They often will, and sort of say, hey, I learned it this way, or why not this, and they ask a lot of questions, and through those questions I think can come learning. But they don't come in with as many preconceived notions of this is the only way to do things, or every time I've done it is this way, or hey, we first need to reconform everything you've done to my way of doing it, and then we'll start making progress. But also putting the more senior developers into the mode of teaching, and by teaching, they're learning, they're having to synthesize concepts and simplify stuff, like we were talking about before, cognitive burden. If you're the only one coding, maybe it doesn't matter so much because the context is always loaded in your head. But the minute you have to share that context with someone else who's also making changes, right? Now you start to like help each other and improve. And also, I think making sure that the expectation is known to senior engineers that there will be junior engineers and that they will bear some of the responsibility for helping to onboard, teach, and show them. Not that they have to become managers, but that everyone on the team has a responsibility to help those who are trying to learn or asking questions. And I think that, again, these first and second order, that you have someone who is contributing, who can grow and can sort of become the team member that you need, also gives like a sense of a narrative arc to the team, right? Like that we were here and now we're there, and like look at the growth. And so for just a host of reasons, I think it's a really important thing to be hiring junior engineers, to bring them on, to have them grow and learn. And then also sometimes projects go through phases, and the project of your phase may be, hey, it's not insane growth right now. We're not able to hire a ton of people. Because of that, some senior engineers may need to or want to move on to other companies or other projects or other things, because there isn't a lot left for them to sort of grow, but there's still a lot to be done. And this is when junior engineers can come in, and for them, that work is super suitable. Whereas for a senior engineer, it may be difficult to justify, the continued sort of growth of their career of doing that work.
Yeah, totally. I mean, like clearly Patrick and I are really invested in growing engineers. I mean, the whole point of this show when we started it so many years ago was that, and it's the point still today. And so this is something that's extremely important. And I personally, I worry greatly about the sort of junior engineers and sort of the future of the field. I think that, engineers have been hit with like some really big whammies. Like the first thing they've been hit by is just exploding college tuition costs, right?
Oof.
Then you get hit with the pandemic and, all of your mentors being, not being around. And now there's all the layoffs and companies saying, I was in a meeting, there was a Austin engineering leadership meeting that I was at. And this person was saying that hey, we just need to get rid of 80% of our company, like Twitter did, and just keep the 20% super productive people. And the thing is that will work in the short term for your company, but there's a tragedy of the commons there where you're kind of it's like when you buy roses from HEB or from your grocery store and they look great, but they don't have roots. And so that these roses will not live very long.
They're already dead.
Yeah, that's right. The cat is dead in the box. And so you're without roots, it's just a temporary facade. And so I do worry a lot about, junior devs just not having a safe place to land. What do you think is going to happen, Patrick? Do you think that if people keep focusing on senior devs, do you think that there's going to be just people are going to get dissatisfied? There's going to be a generational gap or what?
I mean, leaving aside fundamental pivotal shifts from AI or whatever, I think it's a slightly different topic. I think this is where and this will get somewhat, I guess, a little maybe controversial, but I think this is one of the benefits of having capitalist markets is I think companies that will hire junior devs and invest in training them will have a market advantage. And so, two companies participating in the same, so that company that you mentioned, just as an example, I want to lay off all of these junior people. They're not really pulling their own weight right now. We overhired, our fault, whatever. Those people are going to go somewhere. And if not, they might self-organize and kind of learn their own thing and build up a competitor or do something better because they kind of see what wasn't working at the previous company. And so this is where I'm a believer that, having the competition, companies that do this will end up winning out over companies that don't. Companies are willing to teach and hire. Again, like I said, I think they have better practices. And that's not to say in some extreme example that, like you said, somebody could do this and in the short term it works amazing, but then hopefully it doesn't happen, but what if you have a team of super high functioning 3 people, they're working at 110% capacity? That doesn't make sense, I know. But they're working at 100% capacity, super optimal. You think you're a genius. And then one of them, I I work with people, we're getting not that old, but up in age, have a heart attack, have like, a family emergency, and they literally stop working for 6 months. And there's no redundancy, there's no backup. Like, is your company going to like close shop because that's kind of, I guess, the equivalent in financing is people do leverage. They use all this leverage and it works great until it doesn't. And so you seem really genius, I guess is the equivalent of what you're saying about the rose is already cut.
Yeah.
Seems really genius. You're making all this money on leverage, but as soon as, the tide turns even a little bit, you crash really fast because everything is magnified.
Right. And even if like you might say, well, I will let other companies hire and skill up junior engineers, and then I will just hire those people when they become senior engineers. But I think the problem with that is you need to transfer knowledge within your company. I don't think it's not as fungible as people would hope, and so that I don't think that strategy will work either.
Yeah, I mean, you still have to teach them the specific. Most companies still have quite specific things. So even if you say, "Oh, we'll let other people train them and then we hire them," you don't have a culture of training people because you don't do it very often. You hire them back, and then you're going to have a difficulty getting them to adapt, and so you're going to go through a lot more pain and suffering.
Yep. Yeah. Exactly. All right. So. On to mine. So mine are a couple of libraries that let you do real-time text-to-speech, which is now becoming basically an open source commodity, which is kind of amazing. So you can actually, and I'll add a third one to it that just came out this morning, but you can actually have a conversation with an AI, an open source AI in real time. And that just blows my mind. Like you can talk to it, it'll talk back. You can interrupt it and say, "Hey, I want you to talk about something else." Like all these things that we saw in that OpenAI demo about maybe 6 months ago, a year ago, are now becoming a commodity. And here's a few examples of libraries that do this. I think the progress is just absolutely astounding. I mean, it's actually really hard to keep up with. The technology, it's just moving so fast. But this is a really big milestone, and a few different libraries have kind of reached it at more or less the same time.
With the speed of some of this, and like you were joking about earlier, but I kind of find myself thinking about it sometimes. Companies, there's a lot of untapped potential in sort of developing companies around some of these things and just, replacing stuff within bounds. But I think defining those bounds is really important. Like, making sure that there are some, I don't know, call them guardrails or whatever around how some of this stuff is done. But also it's got to be somewhat difficult to, say you're going to build and do an integration with one of these, models that came out. And then to just like 3 or 4 months in, potentially a completely different way of doing it or a different architecture just moves the goalposts. And then you got to decide, like, do we ship on this old thing or do we like completely redo and move to the new thing? And then you end up in this constant cycle of like, oh man, I just got completely, blown away by whatever the next release from whomever is.
Yeah, right. I mean, a good example of this is like the text to image stuff where it wasn't really that commercially practical because the images were just not that good. I mean, they were fun to look at, but like you'd obviously know that this was computer generated, and it basically, within the span of 12, maybe 18 months, it went from that to like you literally like maybe okay. So I take that experts can tell, but like you and I can't tell. Like, if you see a photo of a person, like a profile photo, we can't tell if that's a real person or not. And that is just wild. I mean, if your product was kind of based on one thing, like it just opens up a ton of product opportunities, to your point.
Yeah, there was all that stuff like, oh, they're not good at text, earrings won't be symmetrical, too many fingers. And you're right, they were kind of funny to look at and they looked plausible. And then now you're right, I see pictures posted in some of the sites like, oh, look at this AI trash. And I'm like, if I really stare at it, it looks off. But there's a lot of commercial photography that's airbrushed or whatever that also can look off or not natural. So I think it's like you said, it's a sort of a, whatever, maybe some experts saying these aren't good, but they actually are very convincing a lot of times. And it's really only the fact that the situation is so improbable. Like, oh, a cell phone snapshot of, an elephant parachuting into my backyard. Like, okay, probably that didn't actually happen. So it must be fake, but it's not actually something in the scene that tells you that's not realistic.
Right. And the thing too is, yeah, I mean, if you're in the mindset of, I wonder if this is real or not because someone told me it's fake, well, then you're going to have a very discerning eye, right? But if you're just on the internet browsing, you're not in that type 2 mode of thinking. You're just consuming content. And I think many people will just look at fake images and just think they're real. Like all these stock images, you go to like some random startup that just paid like someone on Fiverr to build a website for them, right? And there's like stock images of people just having fun around a computer. I bet if you replace those with fake images, most people wouldn't even notice.
Yeah. And there are some ethics problems. I will say as well, looking at everything with the discerning eye causes its own problem because there's plenty of actual images taken that look implausible or seem unrealistic as well. And they're are totally legit for variety of things. So you could enter conspiratorial, whatever. Like, yeah, I saw a video of this bad thing happening, but it's just fake. Like it doesn't look real. There's no way that really happened.
Oh, interesting. Yeah, I mean that's a different direction I hadn't thought about. Is if there's a real event, like we're at 9/12 today. Yesterday was 9/11. So like, yeah, I mean, if I'm reading Twitter and I see like some big terrorist attack, my first reaction might be like, oh, that's a fake picture or something. Like, it's kind of wild. All right. So moving on to book of the show. Patrick, what is your book of the show?
Book of the show is not a book.
Cheater.
Warning, tool of the show's not a tool either. So yeah, we got to rename these sections, man. All right. I thought I must have talked about this before, but I Googled through the show notes and I didn't see it. So if I have, I apologize.
I have never heard of this. So okay. I think you're good.
So this is one of those, I know it's like fairly popular now, but I run across fairly popular, like million subscriber YouTube channels all the time that I've never heard about before. It's just a million isn't what it used to be or something.
Yeah.
Sound like an old man now. All right. Anyways, so Thought Emporium is a guy who does, I guess like just call like hobbyist science research. He's my hero. Like I wish I could do this stuff. Like I wish I could make money just poking around like random stuff in my lab. And like, I want to say close to probably half of the stuff he does, like I have at one time or another done, played with or sort of, so it's very fascinating. There's a bunch of sort of one-off projects and long-term projects that he's working on, including topics like genetic engineering. He was recently trying to grow neurons to play Doom. So how do you like grow neurons in a petri dish, hook them up to electrodes, hook that up to a computer and make them play Doom? And not your garage. That's not exactly right because his garage is kind of fancy, but not in a multi-million-dollar biomedical research lab either. The one I linked is just him and his friends like sometimes come up with memes. I think they released one yesterday. It was like, everybody always jokes, what did you take this photo with? A potato? And so he actually built cameras out of potatoes. Not like a potato hooked up to a camera, like the whole camera is a potato. And so like the potato is a pinhole and you use the flesh to sort of get a negative image. Okay. Anyways, the one I linked to in the show notes, you can check it out, is a single-use emergency thermite hot dog cooker. So what would you need to do if you needed to cook exactly one hot dog, like in an emergency situation in a single-use container? And it's just like him figuring out like in a moderately serious engineering, like what is the best way to do this? Like how would I use heat to cook the hot dog? Should I cook it like by itself? Should I cook it in a liquid? Is this actually going to work? How safe is this? Could you make a product out of it? And so if you've never checked them out, definitely do. There was a lot of biohacking initially, like, I'm going to inject genetically modifying materials into myself and do crazy stuff. Nowadays, a little less, but another one that my kids really liked was, is mummy yummy? So let's go through the full process of making like a mummified chicken from the store, grocery store, like legit. We're going to go into reading hieroglyphics and making our own hieroglyphic statements, do the full mummification process with authentic old recipes, and then taste various parts of the mummification fluids and things and
Wait, but aren't
determine if
those
mummy is yummy.
Is that healthy? I mean, or is that sanitary?
So nowadays it would be formaldehyde, and you definitely shouldn't eat formaldehyde. But it turns out in ancient Egypt, they didn't have formaldehyde.
Oh, right.
So you actually could use most of this stuff. So I won't spoil, but if you think it is intriguing to find out if mummy is yummy, you're in the right place.
Okay, yeah, this is awesome. I think this is one of these things where, 40 hours of my life later, I'm like, how did I get on this YouTube channel?
Mine's the opposite. So I watch this and then I find myself on eBay. Like, how could I replicate what this guy is doing? Like, I have so many questions.
Yeah, the YouTube to Amazon pipeline is strong. My book of the show is a project that I started with a friend of mine called Novel Minds. And the idea was there's all these public domain books. A lot of them are required reading for kids. Even the ones that aren't, a lot of them are really good, like War of the Worlds, like classics, right? So I thought, could I use AI to turn them into sort of, I think the word is graphic novels. I mean, not literally a comic book, but just a picture book. So there's just a lot of pictures. The cover is totally redone. And so we did this. So by the time folks listen to this show, there'll be 30 books on this site. I think at the time of the recording, there's maybe 7 or so. But you can basically grab them all for free. If you're on Apple, it will just open in Apple Books naturally. If you're on Android, you'll have to get an EPUB reader, but there's plenty of them for free. And you can read all these classic books with tons of pictures. We tried to do roughly a picture every like 400 words or so. And there's a bunch of technology. I actually gave a talk on how this works that's recorded, and I posted the talk on LinkedIn if folks want to watch that for more technical depth. But if you have kids who are in school who are have to read these books, you could give your kids or your friends' kids copies of these versions. All the text is exactly the same. We haven't changed any of the words. We just added a ton of pictures.
I did not know about this until right now, so I'm actually scrolling through one at present. This is really cool. The style is very consistent. The main character doesn't seem to be, I'm looking at Around the World in 80 Days, but the main character doesn't seem to be super consistent between them. But there used to be books when I was younger that were like this. Like every other page, there was like a hand-drawn illustration, and then they were the like synopsis, like they were kind of, I don't know, 10% of the full book or whatever. They were like concise.
Oh, yeah. So, okay, a couple of things. So one, the version that you're looking at right now is an older version.
Oh, okay.
We did fix the consistency in the newer version. We basically use something like a vector database, foreshadowing. But we kind of encoded a representation of each of the characters, and then when a character is referenced, we added that representation back in. And so now the version that'll be out when we publish the show actually is pretty consistent. But yeah, you're right. The very first version was like thematically completely inconsistent. Like one picture would be black and white, the next picture looked like a cartoon, the next picture would be like a hyper real, and so getting consistency. The second phase was where we got a pretty consistent art style, but the era was all over the place. So like, it'd be 80 Days Around the World, which was set around the 1890s, I think. But there would be like high-speed rail pictures or a guy with like a rocket launcher, And so what we did there was we also injected the era. We figured out the era by scanning the book, and then we inject that into every single image prompt. So yeah, it's been a really, really fun exercise. My goal is ultimately to get these into the Kindle store, although it's pretty difficult because there's a lot of scammers who try to push either fake AI books or public domain books onto the store. And so we're running over a couple of barriers, just trying to prove to Amazon that we're legit. But yeah, it's a fun little book project. And I've had an awesome time actually reading these books. Some of them are a little difficult to read because they're rather old, but a lot of them are awesome.
This is cool. I'm trying to determine how many of these I've read before. So can I have another request? Can you run the generator to give me summaries? So it's all the pictures, but only 1% of the words, so that I could claim to have read all of these books much more quickly than actually read all of these.
That's an interesting idea. I wonder, the reason why I didn't change the words is I felt like if it is required reading for someone, there's a test or something.
A bad idea.
But yeah, but you're right. I mean, for people who aren't reading it for a grade or anything, we could definitely summarize every paragraph or do something like that.
There was so this is really dumb. Okay, we can move on. But growing up, there was this show Wishbone, where it was a little dog. Did you watch this show?
No, I never heard of it.
Okay. Oh my gosh. All right, this is good. All right, I'll make it short. So there's this dog who goes to same idea, various famous plays or books, and the dog is he goes into the story, and then he it's a dog is the main character or whatever in the book, but they're just acting out the book in a 30-minute show, and so you get the arc of the book, the main idea, the gist in 30 minutes for kids, just teach them about different worlds and different a moral story or whatever. But that won't make sense if but that's what I want is the Wishbone, hey, I could hold a conversation with someone, and unless we were doing a book club, they would believe that I had read the book, and I will have benefited from the analogy or the whatever the book is trying to get, without all of the dialogue that happens between characters that, like you said, if it's required reading, it may be very important to read. I'm not trying to denigrate old books, but I also know that I won't commit that time.
Yeah, it's a great idea. Maybe by the time we publish a show, I'll be able to do that. I mean, one simple thing would be, take each chunk, which is around, I think it's 4,000 characters. Take each chunk that's being used to make an image and summarize that chunk down to 200 characters.
All right, I'm excited. This is cool. I don't know how you're going to become rich and become the financier of the biomedical research lab, but
we'll work on that. I'm talking to, was it Tony Stark?
All right, time for tool of the show.
Yeah, if you want to help us
go ahead.
Next Tony Stark, you can subscribe to us on Patreon, patreon.com/programming throwdown.
Okay, that was actually legit. Sorry, I was skipping over, but that is really cool. I'm excited. I have to move on because I feel bad about myself for not contributing to society. Speaking of which, my tool of the show not being a tool and a way to not waste time, to improve your brain, is Escape Simulator. I think I mentioned before playing some Escape games. I recently actually picked this one up in a Humble Bundle. I didn't kind of think too much of it, but it's actually it was pretty cool, and just so much content in this game. So Escape Simulator, it's kind of what it says on the box. It's an escape room simulator. And they themselves have a lot of content for levels that you can play. But they also have a big fan base that is making games of various complexities for you to play. And I really enjoyed doing it. I've been playing it. I've not come anywhere close to beating it because I refuse to use hints. And my daughter sometimes sits and we play together. And, I personally my kids are pretty smart, but way to be impressed with your kids is have them shout out an answer to something and you can't figure out why that is the answer. You try it and it works, and then have them try to explain to you how the puzzle had that answer, and they can't they just intuit it, but it happens way too much. And then you kind of feel bad and you're trying to look at the hints to understand why. Anyways, so Escape Simulator, definitely check it out. Works on Mac OS, Linux, at least in Steam Deck it worked, and Windows.
Yeah, this looks super fun. I'm definitely gonna grab this. Is it like a split screen, or is it internet co-op?
Internet thing.
Okay.
So yeah, that's the only thing I couldn't figure out. I just have one Steam account. I do have two computers, but once you're playing on one Steam library, it won't let you play on another one. So we just sort of sit together and like collaborate on a one player game.
Got it. Yeah, that makes sense. Very cool.
But I could also just buy it under two Steam accounts, and that would probably work fine.
You know, there's a new thing, not to digress too much, but Steam has like a new feature now called family mode, where you can actually say like, this computer is a family member. And then what'll happen is you can both play different games at the same time. If you try to play the same game at the same time, Steam says, hey, you're gonna have to pay to buy a second copy. But then when you do that, then you can play together. So like it kind of handles all of it.
This is good tips. Okay. All right. I'll be back in a few minutes.
All right. My tool of the show is the Cursor IDE, and you can go to cursor.com to grab this. So this is basically GitHub Copilot and all of these things just on steroids at the next level. So they when you start up Cursor, it asks if you want to import all of your VS Code extensions. So it's literally a fork of VS Code. I imported all my extensions. They all imported just fine. The thing about Cursor that really blew my mind was it has like autocomplete that spans the entire file. So for example, I had this app that was a WSGI app. It was basically a kind of a REST API app, and I was converting it to Flask. And so one pattern that I had to go from is the old app, you would return a JSON object, and it would have a status key and then the HTTP status code. So like 200 if it was good, 400 if it was malformed, et cetera, et cetera. And then your payload. And so most of the time in these little handlers, I was returning an object where, JSON object were like status 200, payload is data. Data was some object I created, right? In Flask, you don't return anything from your handler. The handler gets past this response object, and you do response.status 200 and then response.data payload, right? And I changed it. There was a file that had a bunch of these handlers in it. So I changed it in one, and as I was changing it, it let me tab complete to do that. Like it, I put like response.status, like about halfway through the word status, and it figured it out. It's like, what you want to do is status 200, data payload, and then delete the return thing. And I hit tab. That was cool. Then it like zipped down like a third of the way through the file. And it's like, you want to do it here too, don't you? Hit tab. And like, I just hit tab, and it just did all of it. And that blew my freaking mind. Like, I've used, Copilot and Amazon Q and stuff, and they do have some of those magical moments like within, pretty close to where your cursor is. But I've never seen it like this, where it's like, oh, you also want to do this thing at this file over there. It just kept chaining these things to do. And he got it all perfect. Like, there was weirdness around the brackets and all of that, is kind of complicated because I was adding this handler. And so it's actually adding a bracket, but then deleting the return bracket. And it like figured it all out flawlessly. It was really impressive. Again, I think we've talked about this in the past. If you're at a company, make sure you get the right approval. We were just talking about junior engineers. We don't want you to get fired. If you're a junior engineer and you get fired, that will make us sad. Get the right approval, but this is an amazing tool.
That's very cool. Is it in the works for it to be able to do it across files in your project as well? Like if you wanted to refactor all of your files to, use Flask or whatever, like, is there a way to like invoke it to do that or not yet?
I don't think so. I'm trying to remember. It definitely jumps around in the same file. I don't think it has a way to skip to other files yet, but it might. I've just started using it a few days ago. So.
Okay. And what is the zip down? So like it zips down, and then like if you don't want to do it, it just returns you back to where you are. Like I feel like I'll get whiplash.
Oh, interesting. That's a good point. Yeah, I guess I'm not totally sure. So the times where it did this, I took their suggestion every time.
Oh.
I think maybe if you don't take the suggestion, maybe you could hit the up arrow on the key and get teleported back.
I sent a new developer metric, which is how often do you accept the AI suggestion?
Oh, definitely. Yeah, I'm sure if they're not measuring that, they should be. And yeah, I guess you're right. They should pass that measurement along to the company.
No, I'm saying you're like, as an engineer, you get a score, which is like the more you accept the AI thing, the like worse off. You're not adding anything. They could just replace you with the AI. So you need to like, then there's this whole gamesmanship, right? Because then we'll figure it out and we'll just write what the AI said, but change one character so it doesn't count. And then our metric for, novelness goes up.
Yeah, well, it's interesting. I mean, I think that, the next level up from this would be for me to say, convert this kind of like raw Lambda handler into Flask. And it would have just figured out. Because the thing that I had to provide was the knowledge that when you return things, Flask doesn't care. Like it's not going to use that return value. And so like, just like running this code on Flask means that you would just error 500 everything, right? And so like I had to figure that out. And then once I started typing the solution, then it was done. But yeah, I mean, at some point, maybe it will. That's almost like a segue or another thing is, junior engineers now also have to compete with AI. Or maybe not. Maybe it makes them on a more level playing field. That's still kind of an unknown.
I think this is a watch this space. No, that's not how they say that. This is like a watch the future. I don't know what'll happen. I think where I'm sitting now, but this turned out to be wrong before, but like you said, it's sort of the intent still needs to be provided and sort of guided, but people who lean in on it probably see a big improvement before everyone else. And then everyone else sort of adapts or not. And we call it the same thing, but it's not really the same thing. So, it's like programming a website is technically programming, and programming an operating system is also technically programming. They're not really the same thing. Like some parts are similar, but lots of parts are different. And I think we'll just end up with more divergence. So there's some things you're doing, like you're saying, hey, I'm looking for another web framework that may be faster. And it suggests to you to go to, whatever. But then there's also times where you might just be straight up like, this is something that's not been done before and it needs to be written for the first time.
Yeah, that makes sense. It's going to be a wild time. I think these tools will save people a lot of busy work, which is good. But it also means that you will have to memorize the code base faster because you're not going to be sitting there staring at it while you do busy work. So, all right, on to the topic of the show, vector databases. So Patrick, have you ever used a vector database?
No.
All right. But you have used a database.
Yes.
Do you have you ever put like anything other than text in a database? Like have you ever used a database for images or anything?
Yes.
Like that? What did you use for that? Did you just stuff an image into MySQL or what?
Protobuf.
Oh, you put protobufs in the database?
Oh yeah.
Really? So, but that's just like garbage, right? Like, it's unintelligible.
Wow, bro.
What?
You're coming at me.
No. I don't mean it's garbage quality. I mean, when you
Yes,
run a
you're right. You can't.
query,
Yes,
it's
yes.
unintelligible.
Yeah, you can't index it sort of properly. Yeah, you're right.
Yeah, because like when you query, I think if you certain databases, they let you have like a column be a JPEG, and the database kind of knows it's a JPEG, and so when you query it, it will actually show you pictures.
Oh, that's cool. Can you query? Oh, no, it's not. I was gonna say, could you query stuff about it? Like I'm looking for JPEGs where the subject is red.
You could with a vector database.
Oh, okay. Here we go. I'm ready. I'm here. I'm leaning in.
All right. um, so yeah, my mind is still blown by the. So okay, hang on. I got to dive into this a little bit.
No!
So
Really?
if you put a protobuf in a
Yeah.
database, right?
Yeah.
Then I guess most languages have protobuf support, but you would have to like interpret that protobuf before you do anything with that data. So like, your SQL query goes straight to something that like converts the protobuf to like.
Yeah, I mean, you can use it just more like a key value store where the value, rather than a relational database, right? So it becomes more like, hey, I have these keys, and then just have blobs.
Got it. Okay, cool. Okay, so let's build a scaffold up to vector databases. So, okay, people like starting from the beginning, how do computers represent things? So, for example, you open up Notepad, you start typing some letters in Notepad, you hit save, and it saves as a text file. And so, not dealing with Unicode or anything like that, just putting that aside, a text file is basically a bunch of bytes where each byte represents one letter. So there's an ASCII table you can look up, and so I don't remember off the top of my head. I think isn't like 97 a lowercase a or something. It's been a long time.
Oh,
but each letter and each symbol, equal sign, apostrophe, they all map to numbers. And in at least the ASCII format, there's less than 256 of these different things. And so that's one byte in a computer. And so your document is, a byte for each of these letters, including the spaces and all of that. So that's how, traditionally how you could represent text in a computer. So a computer obviously doesn't have a concept really of the letter A, in hardware. That's the way it works. And for images, the same kind of thing. There isn't like any lithography. Is that the right word? But there's no like dark room in your computer. Like there's no physical images in your computer. The way it works is, each picture is broken up into pixels, which is like a really tiny square of an image. Hopefully, so tiny you can't even tell it's a square. And then for each pixel, the color could be represented as the amount of our red, green, and blue representation in that pixel. And so you can imagine, if you have a picture, a bunch of these triples, red, green, blue triples, and you have one for every pixel, and the width and the height of the image, so like what that whole rectangle looks like, and that's how pictures are represented in the computer. Does that make sense? Anything you want to add to that, Patrick?
Yeah, I mean, I think you're right. I think what you're trying to point out is the computer doesn't have a native understanding of most of these concepts. So it just has operation bytes and like data bytes, and the data bytes need an encoding. They need a scheme, and the humans are the one that imbue meaning to those.
Yeah, that makes sense. So, okay. So then we'll get into like, let's say compression. So for example, you might have a document that has the same word a bunch of times. It's like chapter 1, chapter 2, chapter 3. And so every time you have the word chapter, that's going to be 7 bytes, right? To store all of those characters. But if it's always like chapter, 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 section, 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 there's like a lot of repetition there. And so you could actually have a smaller file by taking advantage of all of this repetition. And so one example that most people are taught in undergrad, and I've long since forgotten, is Huffman encoding. I don't know. Do you remember Huffman coding?
Yes. Yeah.
It's something to do with like trees, right? Like you
Yes.
build a tree where
And the
really
prefixes.
frequent. Yeah, maybe you explain it because I've totally.
No. That was good. Yeah. So you like look in your file, and you have to look at the whole file at once and basically decide like, how am I going to assign bits to the most common prefixes of numbers? And each branch of the tree represents sort of like going down that way. And so it can represent a bucket of the prefixes that get concatenated together. And ultimately, that way, the most common pieces use the fewest bits. And then the longer, deeper parts of the tree encode the less common pieces.
Yep, that makes sense. And so you could do something similar for images, right? You could have some kind of delta encoding or other kind of things that take advantage of the nature of the image. But, for images, really, you want to capture the sort of nature of the image, right? So it might not matter that like this single pixel in this one part of the car is like a little bit more blue in the image than it was in real life. Like that doesn't really change the nature of the image. And so now you start getting into what are called lossy compressions or lossy encodings. So for example, one of the most common is where you take these various kind of repeating patterns, so such as like a Fourier cycles or cosine cycles, the cosine wave, right? You take these kind of waves and you compose them at different frequencies and amplitudes on top of each other. So, for example, if you imagine like a zebra, so a zebra is this like really sharp kind of wave where it's white and then it's black and then it's white and it's black. And so if the camera zooms in on the zebra, now the sort of frequency is getting smaller, right? Because those stripes are getting bigger. The camera zooms out or the zebra's running away or something. Now the frequency starts going up. And so what you do is you have a ton of different waves of different frequencies, and there's an algorithm that tries to figure out how you can compose, add many of these waves together to faithfully reconstruct the image. And if you can do that, then you only need to store like the definitions of those waves, like what were the amplitudes and the frequencies of those waves, instead of storing every single pixel.
I mean, I think just to completeness there, you need infinitely many, but if you have some loss criteria, like some amount of thing you're willing to give up, then you can basically chop and only take the top X most important frequencies, and then you'll get back most of the image.
Yep. Yeah, exactly. That's a really good segue to the next part. So now we'll jump into embeddings, right? So we talked about ways to kind of explicitly represent something. So if you have a document and you want to store it, you explicitly represent each individual character. But many times what we want is to know like the overall essence of a document. Like, is this document about cars? Or is this a long document? Or is this document at a really high reading level or at a kindergarten reading level? So these sort of like soft attributes, those sound like kind of yes/no questions, but really there's a lot of ambiguity there, right? It's like there's certain degrees of like how much about cars is this, or how much of this document is at the kindergarten reading level. So these kind of like soft attributes, and then doing things like give me all the documents that are roughly a yes for this question. So it's kind of like a lossy attribute system. And the best way that we have today to be able to answer questions like that is through embeddings. So the goal of an embedding, it's not directly to recover the original document. as we talked about before. So, with Huffman encoding, the goal is to compress something so that you can later decompress it and get back the original thing. In the case of embeddings, the goal is not to get back the original thing. The goal is to be able to answer questions around nearness. If I have a query or a concept, or the query might even be another document, right? What are the things near that query? Semantic nearness. That's the goal. And so because of that, embeddings can be, very, very lossy because they don't really have to reconstruct the original content. And so there's two kind of key ways that embeddings are created. So one way is through contrastive methods. So the idea here is I might say, these two documents were written by kindergarteners. So I know I'm going to be asking a lot of questions about reading level and reading skill for these documents. So I have documents created by kindergarteners. I have documents created by adults. And I randomly pick two documents. If they were both created by the same age group, then I want their embeddings to be closer together. If they were created by a mix of a kindergartner and an adult, if one document was a kindergartner and the other document was an adult, then I want to pull those two documents apart in this space. And so at the very beginning of your embedding process, all the documents are just randomly projected. And so they're just scattered all over the place. But after you ask yourself and answer this question many, many, many times, you end up with, hopefully, you'll end up with sort of you'll end up with many spaces, many clusters, but each of those clusters will be either a kindergartner document cluster or a grown-up document cluster because of all of this pulling and pushing. Does that make sense?
Yeah, I mean, I think the pulling and pushing, now does that happen in like a subset of the dimensions, or are they guaranteed that even in like another dimension they may be far apart?
Yeah, so when you pull or push, you do it in all the dimensions. So it's almost like there's little thrusters on these two documents. There are points in embedded space, and those thrusters are pulling them together in every dimension simultaneously or pushing them apart. And so when you do this embedding, a single dimension has no real meaning because the only meaning was constructed from the distances, the pairwise distances. So like you can't say like dimension 3 is how many times they said the word dog or something. It's because it's all like a composition of all these dimensions.
So you need all of the things you're trying to do this with up front though?
You need okay, so when you're training, you provide a bunch of training examples, and those have to be labeled, right? So you have to know this is kindergartner, this is adult. Once you've trained the model, then you can give it new documents, and you could even ask it like, is this new document a kindergartner or an adult document? And then it would use a vector database to look at like what are the nearest neighbors. And if most of those are kid documents, then that's one way that you can answer that question.
Got it.
So that's one way. Is you give it a bunch of pairs of things that are should be close together or should be far apart. There's another way to do it where it's kind of like a fill in the blank, right? So, for example, here's an example. Let's say I have 3 documents written by a kindergartner, and I give a model the first one, and I give a model the third one, and then I say, hey, generate the second one. Maybe you ask a kindergartner, write a book about dogs, write a book about goldfish, write a book about cars. And you present the AI that you're training, 2 of those 3 books, and you say, generate the third one. And in the beginning, when you start training, the AI is just going to generate random words, just like random characters. It's not going to make any sense. But you have the third book actually written by the kindergartner. And you go to the AI and say, hey, you were wrong. Like, here's the actual answer. And then you do the same thing with like adult books, right? And it turns out that like if all you're doing is kind of filling in the middle, whether it's the middle of a sentence, the middle of a collection of work, or whatever it is, because you're just filling out the middle and you already have the middle, like you know the right answer, you don't actually need any humans in the loop. So like I could just take all of Wikipedia and I could give every sentence to some AI that I'm training and say, like, hey, like fill in the beginning of the sentence or the end of the sentence or the middle. And I know the right answer. And so when it doesn't give me the right answer, I kind of push it, give the right answer. And so this is called self-supervised models. Now, like, if I give it the end of something and tell it to reconstruct the beginning, then when I actually try to use this model in real life, I have to give it the end of something. But if I'm using this to do like ChatGPT, I can't do that. Like you can't say, all right, given the end of what ChatGPT wants to say, give me the beginning. It doesn't work that way. And so usually you're forced to go in the other direction. So you're like, you purposely hide the ending completely. You artificially hide the middle and you give the beginning. When the model tells you the middle, you correct the model. And so because you're never able to look at the future, these are called forward models because they can only take the past and predict the future. And so GPT is an example, without the chat part, is an example of just a pure forward model. So, given like a bunch of things you said, this is your context. What's the next thing that's going to be said? And it's trained on, terabytes and terabytes of text. And then now it generates that token. But along the way of generating that token, it constructs an embedding. So it constructs an embedding first, and then it uses that embedding to predict the next token. And so if you're not interested or you don't need that second part, you can just take the first part, and now you have an embedding of the words that have been said so far.
And so this is why, as like a byproduct of making these chatbots, the companies can also offer an embedding service, is because they need that internally, so they can offer it externally, and it's valuable for the reasons you're describing, which is now if I have text, maybe it's not a chat, it's just I have text and I want a representation of it that I can ask questions about, then I can get the embedding and then do whatever I want with it.
Yep. Yeah, exactly right. And there are vision transformers that work very similarly, where you take a picture, you hide part of the picture from the AI, and you ask the AI to recreate that part of the picture. When it does, you have the real answer because you were the one who hid it yourself. And you compare the AI generation with the reality and you correct the AI. And similar to language, a vision transformer, has a step where there's an embedding representation. So you can take a picture and run like half of the vision transformer, and now you just have this embedding where the picture is going to be kind of semantically close to other pictures that need to get reconstructed the same way. So, all the pictures where you deleted a car and asked the AI to redraw the car, all those pictures are going to have very similar embeddings. But the picture where like you deleted a person from who is in the background of your family portrait, and you wanted the AI to like fill that in with something, all those pictures will occupy like a different space in the embedding. So, yeah, I mean, this is, this gets pretty kind of difficult to explain over the air, but any questions about that part of it?
No, I mean, I think it makes sense. So the idea is you're getting a vector, which I guess we talk about, like it's a list of numbers, and those numbers represent like where in this space it is. And the hope is that for these processes that you learn the ways in which things can be similar or different.
Right. And so, okay, so now let's talk about how to correct the AI. So let's say the sentence was, the quick brown fox jumps over the lazy dog or something.
Yes.
Yeah. So let's say the AI generates the brown fox jumps over the lazy dog. So it got everything right except for the word quick, right? But because it skipped the word quick, every word after that is kind of wrong, right? It's like shifted, right? So you have to develop all sorts of different metrics to be able to say like how wrong the AI was in a way that like helps it learn well. That's at the training side. It turns out the embeddings, you're often trying to use embeddings for a different purpose. Like, for example, you might want to fill in the missing image, the missing part of the image when you're training. But then when you're actually using the model, you want to group all of your images together. So someone can say, hey, this is a picture of me at the beach, find more like this one, which is different than when you're training it. So we call this training serving skew. It's when you use a model for a different use than it's what it was trained, how it was trained. And so what that means is the similarity metric on the embedding, like there's a lot of unknowns there. Like, it might be that the model was just trained to fill in parts of the image. And so it actually does a terrible job of finding similar images. It might just be a coincidence, right? That it does a good job, right? So there's not a lot of theory at this point. And when there's not a lot of theory, the best thing you can do is try a lot of things. No. And so you want to have a variety of different similarity metrics on the embeddings. So a common one is just how close something is, like in Euclidean space. But then there are a bunch of others too. We don't need to dive into all of them. But there's a ton of different similarity metrics. And so, once you've chosen a similarity metric, then you can say, given a point in this space where the point can have a document on it or not, find the nearest neighbors, find the nearest documents to that point. And then you can look at those results and see, okay, does that match what I was hoping from a product perspective?
So the point that you're making and getting the neighbors like a query, but the query is not doesn't have to be a text. Like you said, it could be a picture, it could be whatever. It gets the embedding, and then the goal. Well, maybe I'm jumping the gun here, but the goal of the vector database is to help you efficiently find the things closest to your query.
Yep. Yeah, exactly right. Yeah. So, just like we talked about with the Fourier transform, as Patrick said, you'd need an infinite number of waves to get, perfect resolution, but you're often willing to tolerate, error. Similarly, if you're willing to tolerate error in finding out which documents are the closest, then you can do what's called sublinear approximate nearest neighbors. So the idea is, if I have 1 million documents, I don't need to check the embedding of all 1 million of them to get the nearest neighbors to a point. I can use a variety of different data structures to say, okay, I'm extremely confident that I have the nearest neighbors, but I'm not 100% confident. So for example, maybe there's a partitioning system, and if you fall like exactly just to the left or right of a partition boundary, you might miss what's on the other side of the partition. And And that might happen 1 out of every 10 million times and only affect one result. And so you're more than happy taking that penalty in exchange for just massive, massive speed up. So imagine we're talking like going from like 1,000,000 seconds to search to 6, or something like that. So that's basically what the vector database does. So the vector database has it so where you provide your own embeddings. It doesn't do that part, but you jam a bunch of embeddings into this vector database. It creates all of these data structures, and then you can give it vector queries, and it will tell you the nearest neighbors. And the vector database is responsible for managing sort of the dynamics there. So for example, if you start removing documents and adding different ones, at some point the vector database might be like the data structures might be kind of stale. So I'll give you an example, like an extreme example. Let's say you add a ton of vectors, but only the first dimension isn't 0. So the vector database is basically going to create a bunch of partitions around that first dimension and ignore the rest, right? If you take those documents out and insert a bunch of documents where only the second dimension isn't 0, but you still use the old partitioning scheme, they're all going to fall in the same bucket. And now you don't have that speed up anymore. And so the vector database is responsible for like knowing when to rebalance and re-index, just like your hard drive has to occasionally rebalance the B trees on the folders of your hard drive.
What's old is new again.
Yeah, exactly. And then beyond that, just all of the traditional database things, backups and restores, all of that stuff that we've come to appreciate from databases. Vector databases have to provide that as well.
So if you have, like you mentioned, so you get like Euclidean distance, or you hear like cosine similarity or whatever, if you want to change the metric, do you need, or does per metric, is there needed a different clustering, or is it like one is good for all of them?
Yeah, it's a good question. You basically need a different, the answer is always going to be, it depends on the data, right? Okay. But definitely, you can construct data sets where where each clustering, each similarity metric needs its own clustering, and you can show that that there is a data set where any clustering can only be good in one of these 3 different similarity metrics. So it's possible. Now in practice, I wouldn't be surprised if these database systems just use Euclidean distance for the clustering, and then you pay a slight penalty if you're using something else. I think for 99% of cases, that would be fine.
Makes sense.
And so this is where this is definitely in the category, kind of like authentication. It's in the category of things you don't want to write yourself.
Oh, come on.
It's going to be pretty gnarly. Even some of the top vector databases are only now starting to become mature. So for example, I've used in the past Milvus, which is an open source vector database. And we had issues where when we tried to back up the database, it would crash and we would lose everything. Definitely I would say it's still at the phase where you probably want to store your embeddings just in a regular database as well. It's still kind of early. But every month it gets massively more mature because so many people are using it. The one that so Milvus is good. Pinecone is a enterprise alternative. Pinecone is a lot better, but you're going to pay for it. You get what you pay for there. Another one that I really appreciate is PG Vector, which is an extension to Postgres that lets you have vector columns in an existing table. And that's really nice, right? Because you could have, like a row have like, imagine you're storing houses, your Zillow or something, right? So you could have a row, and the row has like an ID, the address of the house, the number of bedrooms, like all of this explicit information. And then in that same table, you just add a column that's like, embedding. And that column is backed by PG vector, and it works pretty naturally. So you could, this is actually another thing, the approximate nearest neighbors, it assumes that they're all valid, right? But like, for example, let's say you only want 3-bedroom houses that are approximate nearest neighbors, right? That's actually a really hard thing to do because you might pull like the nearest 1,000 neighbors, but they're all 2-bedroom. Now you have to pull another 1,000, another 1,000, another 1,000 until finally you have enough to fill up the 3-bedroom limit that you set. So there's a lot of complexity there. But yeah, these database systems are really good at handling all of that for you.
Yeah, I would love to like find an excuse to use this. It always sounds really interesting and cool. And I know I'm obsessed with tinkering, so love to find a use, but just haven't had one yet.
Yeah, I mean, for me, the one use case that I've found outside of work has been nearest neighbors on my photos. It's not too hard to use one of these open source models, embed all of your photos, and then given one of your family photos, you find all the nearest ones. Google Photos, these other things will do it for you. So it's really more of a fun exercise for you to do than something that's providing a lot of unique utility. But that's been a fun thing that I've been able to do with it. Cool. All right. That is a ramp up on vector databases. If you're doing anything with vector databases, let us know. Give us a shout out. Go on the Discord. The Discord is starting to pick up some steam. A lot of really interesting discussions about career, changing jobs. Should I be a consultant after I leave my company? A lot of really interesting discussions there. So check it out.
Okay, I will take that as a personal message.
Well, I got you covered, Patrick, but
I will be there, but it'll be a bot.
That's right. Patrick's AI will be there and you can interact with it.
So this is awesome. I learned a lot. So thanks, Jason. And thanks everyone for listening.
Cool. All right, everyone. Thanks you so much for supporting us on Patreon. We really appreciate it. And we will catch you all later. Have a good one.